Imagine someone hands you a blowtorch and just a massive pile of bricks, and they tell you to build a functioning five-star restaurant.
Oh, wow. Good luck with that.
Right, and they need it done by tomorrow.
Naturally.
Because that is exactly what stepping into the world of generative AI development feels like right now for, well, pretty much everyone.
It really does. It's the ultimate definition of information overload.
Yeah, you do a quick search for a starting point, right? Just trying to understand this massive technological boom, and you just get hit with this absolute tidal wave.
You really do.
You find incredibly long, highly technical videos, jargon you've never even heard before, and it is so easy to feel like you are just hopelessly falling behind.
Even people who are genuinely technically literate,
Mhm.
they want to understand how these modern AI systems actually function under the hood. But the barrier to entry right now looks like this sheer, unscalable cliff face.
Which is exactly why we are doing this deep dive today. This is your shortcut.
Yeah.
We're unpacking the roadmap of this massively popular, just mammoth resource.
Yeah, that's a good word for it. Mammoth.
We are looking at a generative AI full course uploaded by freecodecamp.org. And just to give you an idea of the scale here, this curriculum spans almost 30 hours.
It's unbelievable.
It originally aired live, and it's kind of wild to think that over 3 million developers have used this specific video. It's taught by Krishnaik, Sunny Savita, and Bakhtiar Ahmed Bapi, and it's basically become their foundational baseline. It has, what, 95,000 likes?
Yeah, something like that. It is a phenomenal, really comprehensive resource. But, I mean, staring down a 30-hour video is intimidating for anyone.
Oh, absolutely.
Even if you follow the industry closely, it's just a massive time commitment.
So here's my promise to you listening right now. We are absolutely not going to read lines of Python code to you today.
Thank goodness. That would make for some terrible audio.
The worst audio. Instead, we're going to extract the core architectural concepts from this multi-day curriculum. We're going to break down the roadmap so you can finally understand how modern AI apps are actually built, piece by piece from the ground up.
And what's really fascinating about this curriculum is that once you strip away the syntax and the command line interfaces,
Yeah.
the underlying architecture of how you build an AI application is actually deeply logical.
Yeah, it really makes sense when you step back.
Right. It follows this really distinct evolution of problem solving.
So let's start with the very first problem developers face, day 1 and 2 of the course. You don't actually kick off a massive AI project by building an AI from scratch, do you?
No, absolutely not.
The curriculum starts by introducing generative AI specifically through the lens of how to use the OpenAI API. So you're essentially just learning how to tap into an existing system.
Well, you have to. I mean, building a competitive large language model, an LLM, from scratch requires hundreds of millions of dollars in, like, data centers the size of football fields.
Right. Most of us don't have that in the budget.
Exactly. The reality of modern AI development for, I'd say, 99% of the industry is that you are just renting the engine.
Renting the engine.
Yeah. Use an API to send a prompt to OpenAI's servers. Those servers do all the heavy computational lifting, and then they just send the text back to you.
So it's kind of like a brain in a jar.
A brain in a jar.
Yeah, like
Oh.
it's this super intelligent entity sitting on a desk in some remote server farm. It processes language beautifully, but it can't actually do anything on its own.
Right,
It
right.
can't browse your local files. It can't interact with the outside world. It just sits there waiting for you to type a question.
That's a fun image, definitely.
Yeah.
But I think a more accurate way to look at it, at least for a developer, is a incredibly powerful engine sitting on a test block.
Okay, I like that.
Right? So it can rev all at once, it can generate massive horsepower, but the car isn't moving anywhere because there's no drivetrain. It's incredibly capable, but entirely isolated from any real-world application.
So once you have that isolated engine, your immediate developer hurdle is getting it to actually act.
Exactly.
And that brings us to day 3 of the course, which is the introduction of an open source tool called LangChain.
Yes.
And we also see the curriculum fold in the Hugging Face API right alongside it on day 4. So if the AI model is the engine on the block, is LangChain essentially the nervous system? Or, sticking to your analogy, the drivetrain that connects the engine to the wheels?
That is the perfect way to frame it.
Yeah,
In the industry, LangChain is known as an orchestrator.
an orchestrator.
Yeah, because building an AI app isn't just about asking a question and getting a text response back.
Mhm.
It's about automating a whole chain of events.
Okay, give me an example.
Okay, let's say you want your AI to read an incoming customer support email, categorize the tone as, say, angry or neutral, and if it's angry, automatically trigger a Slack message to a human manager.
But the OpenAI engine can't send a Slack message.
Precisely. The engine can only read the text and output a response saying, hey, this customer is angry.
Right.
LangChain is the framework that takes that text output, routes it over to a totally different API, in this case, Slack, and triggers the actual action.
So it's literally orchestrating the flow.
Exactly. It orchestrates the flow of information between the language model and the external tools. And that's exactly why the instructors introduce Hugging Face at this exact same point in the architecture.
Let's actually pause on Hugging Face for a second, because I feel like that's a term thrown around constantly in AI news.
Yeah.
What actually is it in the context of building one of these apps?
Think of Hugging Face as like the GitHub of machine learning.
Okay.
It is a massive, collaborative, open source hub. Let's say you don't want to pay OpenAI every single time you need to analyze an email's tone.
Because those costs add up.
They absolutely do. So on Hugging Face, you can find thousands of smaller, highly specialized, totally free models built by researchers all over the world.
Oh, wow.
And LangChain is the universal adapter. It lets developers easily swap out the massive OpenAI engine for a smaller Hugging Face engine without having to rewrite their entire application.
That is incredibly efficient. Okay, that makes total sense. You have your engine and you have your LangChain drivetrain. But by day 5, the architecture hits a massive known wall.
The amnesia problem.
Yes. For developers, the immediate hurdle with these models is their inherent statelessness. They have total amnesia. Every time you send a prompt, it's treated as an entirely independent event.
Which is a huge problem if you are trying to build, say, a chatbot or an automated assistant.
Right.
Like if a user says, I'm having trouble with my account, and the bot says, what is your username? And the user replies, Bob123.
An isolated model will just look at the text Bob123 and have absolutely no idea what context it belongs to.
Exactly. It forgot the first half of the conversation, the millisecond it finished generating its reply.
So on day 5, the curriculum spends a significant amount of time teaching developers how to implement memory into LangChain, which leads to deploying an actual project on days 6 and 7.
But how does that memory actually work? Because it's not really memory, is it?
No.
It's essentially just a mechanical workaround. It is entirely a workaround. It's based on managing what we call the context window.
Context window.
Yeah, you see, you pay for AI processing by the token, which roughly translates to syllables or words. Every prompt you send costs tokens. Because the model has amnesia, LangChain basically has to act as a short-term memory loop.
How so?
Behind the scenes, LangChain takes your newest reply, bundles it together with the transcript of the entire conversation up to that point, and hands the whole package to the model.
Wait, so it's constantly rereading the entire history of the chat just to remember what happened 2 minutes ago?
Yeah.
That sounds wildly inefficient.
Oh, it is. And as the conversation gets longer, you are sending more and more tokens with every single press of the enter key.
Which means you're paying more.
You're chewing through compute costs.
Yeah.
And eventually, you hit the model's hard limit, that context window, where it simply cannot process any more text. And it just starts forgetting the beginning of the conversation.
And that perfectly sets up the next major evolution in the course. The instructors just used LangChain to build and deploy a basic project, proving they can cure short-term amnesia for a quick back-and-forth chat. But if LangChain creates memory by looping the chat transcript,
Right.
what happens when the context you need isn't a 5-minute conversation, but like a 10,000-page corporate archive or an entire library of medical journals?
The short-term loop completely collapses. You cannot bundle a 10,000-page PDF into every single prompt you send to the model.
It would just crash.
It would exceed the context window instantly. And even if it didn't, the compute costs would bankrupt your project in an afternoon.
And this is where the curriculum takes this massive pivot, days 8, 9, and 10. They move away from the AI models themselves and dive deep into mastering vector databases. Specifically, they highlight platforms called Pinecone and ChromaDB.
Yes.
And I really want to push back on this on behalf of everyone listening.
Go right ahead.
I just don't get this pivot. We've had robust databases for decades.
We have.
If I want an AI to reference a specific legal contract from a 10-year company archive, normal SQL databases already exist. They can instantly retrieve documents using keyword search, or even just an Excel spreadsheet. Why are developers reinventing the wheel with entirely new, fancy-sounding, highly complex vector databases?
Because traditional keyword search is incredibly brittle, especially when you're dealing with natural language.
How do you mean?
Let's look at your legal contract example. Suppose a lawyer asks the AI, find me instances of a breach of contract regarding the software delivery. A traditional SQL database is going to look for those exact characters.
Right, the words breach and software.
But what if the actual document says the vendor failed to fulfill their technical obligations by the agreed upon deadline?
Ah, the traditional database returns zero results because the specific words breach and software aren't clustered together in that exact phrasing.
Exactly. Traditional databases search for syntax. They organize like alphabetical order. Vector databases search for meaning. They search for the concept, the vibe of the query. Yeah. And to understand why this is revolutionary, you have to understand a concept called embeddings.
Okay, let's unpack embeddings. How does a database understand a vibe? How do words turn into meaning?
Okay, so before a document ever goes into a vector database, it is passed through an embedding model. This model reads the text and translates it into a massive string of numbers, a vector.
Okay.
Think of it as assigning the document a specific coordinate in this huge, high-dimensional mathematical space. Because these models have been trained on billions of sentences, they actually understand context.
Interesting.
They know that the word puppy frequently appears in similar contexts as the word dog, even though they are spelled completely differently.
So they map out concepts spatially.
Yes.
So in this mathematical galaxy, the coordinate for apple is placed very close to the coordinate for orchard, and it's placed very far away from the coordinate for, like, car brakes.
You've got it perfectly. So when your user types a complex, messy question into your app, LangChain intercepts it. It translates that question into its own numeric vector coordinate. Then it goes into the vector database like Pinecone or ChromaDB and instantly pulls the documents that are mathematically located closest to that question's coordinate.
That is wild. It finds the answer based on conceptual proximity, bypassing the need for exact keywords entirely.
And this architecture solves the single biggest liability in the generative AI industry today, which is hallucinations.
Right. The tendency for these models to just confidently lie to your face when they don't know the answer.
Generative models are designed to be people pleasers. They just want to predict the next most likely word. If they lack the facts, they will invent them just to complete the pattern.
Which is terrifying for a business.
Oh, totally. But by introducing a vector database, you change the entire flow of information. You implement an architecture called a
Or RAG. Yes, I saw that extensively in the sidebar of our source material. There was this highly viewed IBM technology video discussing the ongoing debate, is RAG still needed? Walk us through what that actually means.
RAG stands for Retrieval Augmented Generation.
Yeah.
It is basically the absolute gold standard for building reliable, enterprise-grade AI right now.
Okay.
Let's look at the workflow. A user asks your app a question. Instead of sending that question directly to the language model and just, crossing your fingers that it knows the answer.
Right, hoping it doesn't hallucinate.
Exactly. LangChain intercepts it. Step one is retrieval. It goes to the vector database and fetches the highly specific factual documents conceptually related to the query.
Okay, so it pulls the exact legal contract or medical record.
Step two is augmentation. LangChain takes the user's original prompt and augments it by pasting those factual documents right underneath it. And then step three is generation. It hands this massive fact-filled package to the language model with a strict system instruction. It says, answer the user's question, but only using the facts provided in this text.
Retrieval,
You're
augmented, generation,
Very
or RAG.
Yep.
You retrieve the facts, augment the prompt, and force the generation to stay within the boundaries of reality.
That is exactly why this course spends days focusing on Pinecone and ChromaDB. Without vector databases, RAG is impossible. And without RAG, an AI application is just a toy that might lie to your customers.
So let's zoom out for a second and look at the whole machine we've built here. We have the engine, which is the LLM processing the language. We have the drivetrain, the LangChain orchestrator moving the data around. And we have the memory bank, the vector database, providing that factual, conceptual grounding.
The Trinity.
Right. And once you grasp this trinity, the mechanics of modern AI become so clear. But the curriculum doesn't actually stop there.
No, the final phase of the course shifts its focus entirely.
Right. Starting on day 11. After establishing this whole architecture, the instructors introduce Meta's Llama 2 model.
Yeah.
Then on days 12 and 13, they have the students combine everything into this massive end-to-end medical chatbot project.
That's a huge milestone in the course.
And finally, they conclude the whole thing by diving into Google's Gemini Pro models. I have to challenge this structure a bit.
Yeah, lay it on me.
If OpenAI works beautifully with LangChain, and we already know how to use it from day 2, why are developers being asked to switch to Meta's Llama 2 or Google's Gemini at the very end? Aren't developers just collecting AI models like trading cards at this point? Why overcomplicate the stack?
It looks like redundancy on the surface, I completely agree. But it's actually the most critical lesson in the entire course.
Really?
Yes, the curriculum is moving from teaching you how to build a machine to showing you whose engine you should plug into it. It's about vendor lock-in, privacy, and ultimately control.
Break that down for me. If LangChain makes all the models plug and play, why does it matter whose engine I use?
Let's use the course's medical chatbot project as the perfect case study. If you are building an AI assistant for a hospital system, you have strict, non-negotiable constraints.
Well, accuracy is obviously paramount, which we solved using the vector database and RAG.
Yes. But the second constraint is compliance and patient privacy.
Ah,
You are dealing with highly sensitive, high PA-protected medical records. If you use OpenAI's API, your LangChain orchestrator is taking private patient data, sending it out of your hospital's secure network over the open internet to a server controlled by a massive third-party corporation.
oh wow, I hadn't thought of that. The data literally has to leave the building for the AI to read it.
Exactly. And for most healthcare providers, that is a massive compliance violation. You cannot rent an engine if the engine sits in someone else's corporate headquarters.
Right.
And that is exactly why the course introduces Meta's Llama 2. Llama 2 represents the open source movement. Unlike OpenAI or Google, Meta released the actual underlying weights of the Llama 2 model.
Meaning anyone can use it.
Developers can go to Hugging Face, download the entire engine, and run it locally on their own private hospital servers.
So you bring the model into your own basement, you lock the door, you pull the Ethernet cable out of the wall, and the patient data never leaves the building.
That is the real power of open source. So let's look at the flow of that medical chatbot now. A patient asks, what were the side effects of my last prescription?
Okay.
LangChain takes that query, pings the local vector database to securely retrieve the patient's file, augments the prompt, and hands it to the locally hosted Llama 2 model to generate the answer. The entire pipeline happens behind the hospital's firewall.
And then the course contrasts that by showing Google Gemini Pro at the end, which is a massive proprietary competitor, a closed ecosystem like OpenAI.
Right. It teaches developers that as an AI architect, your job isn't just writing code. Your job is evaluating trade-offs.
Right.
Do you need the absolute cutting-edge reasoning of a proprietary model like Gemini Pro for general knowledge? Or do you need the strict patient privacy and zero-cost inference of an open-source model like Llama 2? Because you use LangChain, swapping them out is literally just changing a few lines of configuration.
It really brings the entire 30-hour curriculum into sharp, practical focus. It's not just learning Python syntax.
No, not at all.
It's learning how to solve complex, real-world business constraints.
It really is a masterclass in modern systems architecture. And honestly, it demystifies the magic.
It completely does. And, it's incredible that this level of education is just sitting out there, accessible to anyone willing to put in the time. Community-backed efforts like this, funded by core sponsors like Scrimba and championed by open source supporters like Dav the Coder and Jedi or Sith, they're what keep the internet an engine of opportunity.
Absolutely.
Because of resources like this, you, listening right now, don't need a computer science degree to understand the reality of this technology.
Knowledge is always most valuable when you can see the underlying patterns. You don't have to write the code to understand the mechanics of the machine.
Exactly. You now understand the foundational trinity of modern AI. You have the model, the engine that processes language. You have the orchestrator, like LangChain, the drivetrain that connects the model to external tools. And you have the vector database, the memory bank that cures hallucinations by organizing facts mathematically by meaning.
It's all just modular assembly.
Yeah. You no longer need to feel overwhelmed when these terms dominate the headlines. You can see past the magic trick.
But, understanding the mechanics of today raises a massive question about where this is all heading tomorrow.
Yeah, let's look at the horizon. In the peripheral source material we reviewed alongside this course, there was this really fascinating detail. Right next to the course's final webinar on the future, there was a recommended talk featuring Mo Gaudat, an ex-Google executive.
Oh, yes.
The title of his presentation was How to Position Yourself Now Before the Next AI Phase 2026 to 2027.
Which is a very specific and very imminent timeline.
It is. So I want to leave you, our listener, with a provocative thought to mull over. We just spent this time breaking down the incredibly complex, highly visible mechanics of how AI is built today. The orchestrators, the RAG pipelines, the token limits, the vector databases.
Right.
If this 30-hour mega course represents just the foundational baseline of generative AI today, what happens in 2026 or 2027?
Consider what happens when the tools become so advanced that all of this complexity completely abstracts away.
Exactly. What happens when these complex vector databases and orchestrators become entirely invisible? When they're just silently running our daily lives, our healthcare, our legal systems in the background without us even realizing it?
It's wild to think about.
The blowtorch, the bricks, and all the raw ingredients are going to be hidden away in the kitchen. All the public will see is the five-star meal arriving at the table.
It's a profound paradigm shift. The mechanics we study today simply become the invisible infrastructure of tomorrow, like plumbing or electricity.
So the question you have to ask yourself is this. Are you positioning yourself to be an architect of that future? Someone who understands how the kitchen operates and how the ingredients interact? Or are you just going to be a user, sitting at the table eating whatever the system decides to serve you?
It's the fundamental difference between understanding the systems that govern your world and just passively passing through them.
Think about that the next time you feel overwhelmed by the tidal wave of AI news. You don't have to build the entire system yourself today, but knowing how the engine works changes your perspective on everything.